Right, now there are many different factors which influence the rate of the reaction, and it affects it. It either makes reactions happen faster or slower. Now I want you to read page 13 and 14 in your textbook, but I'm just going to go over with you what is the most important things. Now the first thing that affects rate of reaction is the nature of the reactants. Now the nature of the reaction basically means what the reactants are. Now you don't need to know too much about that, but just some compounds naturally react more than others. Some are just more reactive. Right, the second thing and a very important thing that affects rate of reaction is the temperature. Now temperature, the definition of temperature is basically average kinetic energy of molecules. Now since temperature is kinetic energy of molecules, the more the temperature or the higher the temperature, the more kinetic energy compounds will have. And if it has more kinetic energy, it will collide more with other molecules. And if more of them collide, there is a chance that they will collide in a correct orientation, which means that they will form more products and the reactants might happen faster. So here is an amazing summary of what happens when the react temperature increases. So if you increase temperature, the average kinetic energy of the molecules increases. That means they will move faster, which means they will have more kinetic energy, which means they will have more kinetic energy compared to activation energy. Then they will actually collide and collide effectively in the correct orientation. And the more effective collisions there are, the faster the reaction will happen. So basically, temperature is almost, we can say, directly proportional to rate of reaction. The higher the temperature, the higher the rate of reaction. Right, the next thing that affects reaction rate is concentration. Now concentration only applies in solutions, which is basically when you have something dissolved in a liquid. Now concentration is directly proportional to the rate of the reaction, which means the more concentration you have, the higher the reaction will, or the faster the reaction will happen. And that is because more concentration means you have more compound or you have more molecules. And the more molecules you have, the more chance you have of that molecules having a high kinetic energy, which is greater than activation energy. And the more molecules you have, the more collisions you will have. And the more collisions you have, the more they can collide effectively in the correct orientation. And the more effective collisions, the more product you will form, which means the reaction rate is higher. So basically, concentration is directly proportional to reaction rate. The higher the concentration, the higher the reaction rate. Right. The next thing that affects reaction rate is pressure, and pressure only applies to gases because you can only put pressure on gases. Now, pressure is inversely proportional to volume, which means the more pressure you have, the less volume you have, so the less space you're taking up. Now, if you have more pressure, it means you have smaller volume, which actually means that the concentration in that particular space is more. And since you have more molecules, it means you have a more chance of them colliding with each other because they have enough kinetic energy. And again, more collisions means they can collide effectively in the correct orientation, and the more effective collisions, the higher the rate of reaction. So again, pressure you can say is almost directly proportional to reaction rate. Right, the next thing that affects reaction rate is the reaction surface area, and this only applies to solids. Now, surface area is basically how much area you have around a compound which will come into contact or be exposed in a chemical reaction. And it can only be applied to solids because you can only break up solids into more surface area. Now, the higher or the more surface area something has, it means more of that surface is actually exposed to being collided. So more that is being exposed, it means they will collide more, and the more they collide, the more effective collisions, and again same thing, the higher the reaction rate. Now when you're dealing with solids, a solid can either be a big piece of solid, or you can crush this solid up almost like into a powder, and when it's crushed up into smaller pieces, that's when it will have a higher surface area. So anytime you crush a solid, it will have a higher surface area, and the higher the surface area, the higher the reaction rate. Then that is a good example with grandpa. Remember grandpa, when you have headaches, first grandpa came up with a tablet, and the tablet is basically a small surface area because it's just one big tablet, so it works but not as fast. Then if you have grandpa powder, you're taking that tablet and crushing it into powder, so now you have so many molecules. You don't just have one piece, you have thousands of pieces, and they all have a higher surface area now. So because they have a higher surface area, they can all collide effectively, so the reaction rate is higher. And the last thing that affects reaction rate is a catalyst, and a catalyst is just a chemical that increases the reaction rate, and it does that by decreasing the activation energy of a reaction, and that's all it does. It doesn't do anything else. It doesn't make a reaction happen. It doesn't make more product. It doesn't make anything else. The only thing a catalyst does is decreases the activation energy of the reaction, and that makes the reaction happen faster. And here you can see a nice table of what a catalyst does and doesn't do. So it basically creates a path of the reaction by reducing activation energy, and this increases the rate of the reaction. What it does not do is initiate a reaction, which means a catalyst can't start a reaction. If the reaction is not going to start, if you add a catalyst, it still will not start. The catalyst doesn't get used up during the reaction. It just stays there. It's just like something you put in and you take it out exactly the same and unchanged. And it does not change the delta H value, which means it doesn't change exothermic into endothermic or endo into exothermic. It doesn't interfere with anything besides changing activation energy. Right, so here are the 6 things that affect the rate of the reaction, and I want you to know these things perfectly because you will be needing it in the next section, and you need to know exactly how it works. So again, nature of compound. Some compounds just react faster than others. Temperature. The higher the temperature, the higher the reaction rate, so it increases reaction rate. Right, RxN is short for reaction. Concentration, it only applies to solids and liquids, and again, if you increase concentration rate, reaction rate also increases. And pressure, again, if you increase pressure, reaction rate increases. And surface area, only for solids. If you increase surface area by crushing it down into a smaller powder or into smaller pieces, reaction rate will also increase. And catalyst, it only lowers the activation energy, and that is how it increases reaction rate.